Okay, so in this example, I'm going to walk through a u substitution where u substitution is given, which means it's absolutely required to use it. You cannot integrate this. I actually take that back. You actually could through a different method, but we'll use a u substitution. So when you do u substitution, regardless of what the substitution is, we always want to find its derivative, as in du dx as well, so that when we do the substitution, all of the x variables must be replaced, but also the dx. So therefore, I'm going to also rearrange this. Du equals 1 dx. Obviously, I didn't need the 1 in there, but anyway, so then when I go to substitute, this is where u substitution, in this case, is required. That I notice that my denominator clearly matches what I'm being told to use for the substitution. And then dx is simply du. But I have a problem on the top, in that the x squared plus 4, I would suggest that a lot of people would initially misconceive that that factors into x minus 2 and x plus 2, and therefore the x plus 2 can cancel with the denominator, simply because they're not paying attention to details. The x squared plus 4 does not factor. So what we often need to do in this case, regardless of what is given, we often need to somehow manipulate that u substitution. In this case, we're simply going to solve for x, as in subtract 2 from both sides, and then substitute in for x in the numerator, because the denominator is a one for one match with the u substitution given, and that x is squared. So now replace the x with u minus 2, square it, plus 4. And then in this case, it's simply from here, algebraic manipulation is in expand the top, please don't forget your middle term. If you do, you probably should be in 2 unit. Being pretty harsh, but that's a really low level mistake to be making there. And then in this case, this is where people often struggle, especially with problems like this in a 2 unit paper where this is my starting point. I can actually separate the terms, as in u squared on u is simply u, minus 4u on u is simply 4, and then 4 plus 4 is actually 8 on u. And now we can integrate each term independent of each other. So that becomes u squared on 2 minus 4u, and then plus 8 ln absolute value of u, because of the domain restriction with ln. And in this case, a lot of people, again, not paying attention to detail, working too fast, they believe they're done, they tack on the plus c and they move on. Or if this was a definite integral, another area to pay attention to is, if it was definite, making sure that you change your upper and lower boundary that was in terms of x to in terms of u, so that then you can evaluate appropriately. So a couple other pieces of information there. So here, if I back substitute, as in replace my u's with x plus 2 quantity squared, stick the 1.5 out front, minus 4 x plus 2 and plus 8. If you leave that 8 in front and don't use a power rule for logs, you absolutely need to include these absolute values, again, because x plus 2, depending on the x values, could potentially be negative, and you want to make sure that the ln of that is positive. If I rewrite it using the power rule for logs, to the power of 8, well, to the power of 8 ensures that that is actually a positive value, so I don't need those absolute values anymore when I use a power rule. for logs. And of course, in both cases, regardless of where you stopped, you definitely need the plus c, because this is an indefinite integral.